Okay, so yesterday we talked about relating f, f prime, and f double prime, and we're going to go over a different type of example today. So yesterday I gave you guys a table and I asked you lots of questions having to do with f, f prime, f double prime. And on this problem, we kind of started this yesterday, but just to remind you, you're given a graph of f prime. And by the way, it does say the domain is all real numbers, so let's put arrows at the end. If it said this was over a closed interval, what would we put at the end? Endpoints, right? Okay, so since it said all real numbers, we'll put arrows. So that's going to affect our intervals. We might have infinity in some of our intervals. And it does say we have to justify everything in terms of f prime. So we talked about this yesterday. That's why it's already written here. You might have it written on your paper. But just as a reminder, every time our justification is going to be because f prime, blah, blah, blah. Okay, so for part A, it says over what intervals is f of x decreasing? I am not asking you where this graph is decreasing. I'm asking you where f is decreasing given this f prime graph. So if you start with the justification, it actually makes this a lot easier. So what would be the justification for f decreasing? Because f prime is negative. Okay, so once you write that justification, then you know what you're looking for. You're looking at f prime and going, where is this graph negative? So that would be like down here and down there. Okay, where is this graph below the x-axis? So our intervals are going to be negative 2, I can't read, negative 2 to 0, and then union that with 2 to 3. Okay. And I'm going to erase this just because it really only applied to that one problem, this little bit. So then what would our justification be for increasing? F prime is positive, which would, in this picture, relate to where this graph is above the x-axis. So we would start with negative infinity, and we'd stop right here at negative 2. Okay? And then we'd pick back up with 0 to 2. Again, this is where this graph is positive. And then I'm going to have to squeeze in the last one, 3 to infinity. Let me just move this because over. Okay? So again, I wasn't looking at these words and picking out on this graph. You had to make the connection between f and f prime. So then on part C, it's talking about f being concave down. Now typically our justification for concavity has to do with the second derivative being negative for concave down. But if the justification has to be in terms of f prime, what would we say? F prime is decreasing. Very good. So this is where we would look for where this graph is decreasing, because where this graph, f prime, is decreasing, the graph of f, which is not shown here, would be concave down. So that would be negative infinity to, where would we stop decreasing? Negative 1. So we'd stop at that relative min, and then we'd pick back up at the relative max, 1, and go all the way down to 2.5. All right, so this problem does not have, it's not asking you for concave up, but do you understand how you would find it? What would you be looking for on this picture? Where this picture is increasing. Good. Okay, then we get into relative max. And even though I've already said this, that this is not the graph of f, I know what students want to pick. They want to just pick 1. They're like, that's the relative max. And that is the relative max of f prime. It's not the relative max of f. So we're going to start this the same way we started the other ones. Because f prime, and then what would be the justification? What is f prime doing at a relative max?
Change signs.
Yep, from positive to negative. And if you've forgotten that, just think about like what a max would look like. The slope would be positive, f prime would be positive, then turn negative.
Can you use your little table?
You can use the chart for this.
Did you know that the chart is just...
Yes.
Yeah.
Mm-hmm. It's cool, isn't it? All right, so now we have to look where this graph changes positive to negative. So watch this. We haven't done this yet. One of those places is at -2. Do you see how as we go from left to right, the y values change from positive to negative? It's crossing the x-axis from positive to negative. So x equals -2 is one answer. What's another answer? 2, for the same reason. As we go left to right, I'm emphasizing the whole left to right. You can't do this thing backwards. F prime changes from positive to negative. All right, what about a relative min? Where would those x values be? So this would be where this graph has a relative min. But what I want to know is where does the graph of f have a relative min? So it's kind of confusing if we start over here. So I should take my own advice, right? And we should write the justification first. If you write the justification, it goes from being an abstract problem to a pretty black and white problem. So the justification is f prime changes negative to positive. So what I'm looking for is below to above as we go from left to right. So what's one answer? 0. Where's the other answer? 3. Okay. Again, point of inflection. With point of inflection, we think about second derivative, but we've got to relate this to the first derivative. So let's think this through. A point of inflection is where the second derivative changes signs. So it's where the first derivative changes, say, direction, increasing to decreasing and vice versa. So it's where the first derivative has relative extrema. Okay, this is where we're going to pick out these points right here. The points that I'm highlighting here in blue, these are relative extrema of f prime, but they are points of inflection on f, which again is not shown. And that's the weirdest part. Now, if you want to just list all these numbers out, you can do it like that. Just make sure you put you put it in set notation if you do that. Okay, again, not intuitive to most people. Write the justification first, then say, okay, how does that relate to this graph? Start with what you know, and then figure out the other part. All right, now we have to make a sketch. Okay, so always on these where you have to make a sketch, they're going to give you a point somewhere in the problem. Here it's -3, 1. So let's go ahead and make that point nice and big, and whatever I graph has to go through it. Okay, the next thing I would do here is mark off where this graph is increasing and decreasing. Okay, so we already know that this graph is increasing from -infinity to -2. Okay, so I'm going to draw a little, and we figured that out in part B. So I'm going to draw this kind of at the top, and this is going to be my guide. Okay, we're also increasing from 0 to 2. This is not something you have to do. It's just a strategy to help you kind of make your way through the problem. And then 3 to infinity also increasing. So then all these other spots would be decreasing, which we also found in part A. Now, on the problem we did yesterday, we had to really consider concavity. On this one, as long as you keep your curves going pretty decently, you don't really have to mess with concavity. You could, and you'll still get the right answer, but you don't really have to be that specific. So watch what I'm saying with this. My graph should be curves. There shouldn't be any cusps or any weird stuff like that in my graph. There wasn't an f prime, so there's not going to be an f. All right, and so watch what I'm going to do. I'm going to increase until my little notes up here tell me to stop increasing. And that's what we call a relative max, which we found in part D. So everything I'm about to do is going to back up all that stuff that we found in the earlier parts of this problem. Okay, now I'm going to decrease. Notice it's just rounded curves. And I'm going to decrease and at some point change concavity. And I don't know how far down this should go, but I know that by the time I hit 0, I've gotten a relative min. And then I start increasing. Again, I don't know how low this point should go. This is why this says sketch a possible graph. Just a sketch. Okay, when you're going up here, the way you know when to top out, so to speak, is when you know you should change from increasing to decreasing. Okay, again, I don't know if these loops are too big or too small. It's just a sketch. So if you wanted to, you could go back through everything we did and kind of confirm the answers, like with concave up and concave down and points of inflection and all that. Okay, but this is good.